Welcome to our process control project, controller project. This is Iron Buffalo, and we're going to give you a little info about what we did for our project here. As you can see on the screen, we have this apparatus, and what we built was essentially a solar panel that could track light, and it would follow wherever the greatest light was to increase the amount of solar energy that it receives. And on the screen we have our apparatus, and to start we have our Arduino here that we're controlling everything from there. We have a servo motor, as you can see at the top of the screen, that connects into our Arduino, and then we also have two photodiodes that connect into our breadboard here. The breadboard then, with these resistors, converts the current that the photodiodes are reading into a voltage, and the voltage is then read on the Arduino and then onto the through Python. And so what our system is doing here is we have two photodiodes because we're taking the difference between the photodiodes and we're wanting that difference to be 0, because if it's 0, that means that the board that the photodiodes are resting on right here is going to be pointed towards the greatest light source. And we have this divider in the center to help guide that board, because if it's not at the greatest light point, there will be a little shadow over one of the diodes and it'll adjust to be able to reach that point where the greatest light is showing onto the board. Now Mark is going to explain a little bit about the coding behind this project.
All right, I'm going to talk a little bit about our code. So first of all, we started writing a step test. We are stepping from 0 to 90 degrees to 65 degrees. And between each point, we are waiting 1/10 of a second. So this is a 2-minute step test since there are 200 points. After we did the step test, here's our graph. The first graph, you see the sensor readings, and if it's a 0, that means it's pointed in the direction of the greatest light. And the second graph, you see position. So our next cell, we run an optimization code to try to fit an FOPDT model to this data. You can see here where we set our FOPDT model, and we're using SciPy's minimize function to minimize the error between our points that we measured and our FOPDT model. You can see here it's not the best fit, but it'll work for our purposes. After that, using those FOPDT parameters, we found tuning parameters for a PID controller. We used IMC moderate tuning, and you can see here our values. This is we started out using a PI only controller, but we have ended up using a small derivative term as well. So in this last cell, we actually implement our PID controller, and we spent quite a bit of time trying to optimize our controller parameters, but as it is, it gives us a pretty good controller. You can see the results of one of our actual tests, and it oscillates a little bit, but this is because we're waving our light around and it is giving, and that causes it to move in the direction we have our light in.
Here you can see the performance of our system. In a dark room, we use these same controller parameters that Mark mentioned, and you can see that it follows quite well a flashlight being moved around. It has very rapid response to changes in light, and will also show in a not dark room that it responds to subtle changes of light as well. Here, our system responds to the light coming from a window on the top of the screen. You can see the system slowly turning to point towards that light. If we adjust the system, it will again turn and point towards the greatest light source. We can also add a disturbance variable with this flashlight, and it will continue to optimize the incoming light. And when that disturbance variable is removed, it will adjust to again point towards the greatest source of light. We are very excited about the completion of this system, and we feel like there are different applications that could be applied to. For example, solar panels could use this system to optimize the light coming in. In addition, you could add this to a camera to point towards the greatest light. For example, security camera being used at night would be able to track anybody coming towards the camera with a flashlight or anything like that. We thank you for your attention to this video, and
Iron Buffalo signing out.